exactly. And there's a very interesting phenomenon that takes place in people that have chronic anxiety, or for people who essentially stop accessing alternate rules and responses to these signals. And this is, I think, what is showing up in chronic anxiety, certainly in certain forms of depression, and when people enter states of rage and dysregulation, is that normally we know based on neuroimaging that the prefrontal cortex is essentially leading the response of this anterior cingulate cortex and the insula. So information is coming up from the body into the insula and then being fed to the prefrontal cortex. But then the prefrontal cortex is actually in a position to lead responses, and it essentially is acting like the coach of a team. And the team is all these structures like the ACC and the anterior cingulate cortex and the insula, the heart rate and so forth. What happens in individuals who have chronic anxiety or damage to the prefrontal cortex or dysregulation of these circuitries is that order actually reverses. The insula and ACC start leading and directing the response of the prefrontal cortex. And I think, we see this I'm sure you've seen this clinically in individuals. And while this isn't necessarily a discussion about society at large, I mean, we see this in dysregulated arguments and dysregulated combat, where people is essentially losing themselves, and they default to what appears to be very primitive rule set. And it may or may not be the appropriate one. Yep. But you and I, of course, have the good fortune of knowing a number of people who've worked in special operations and things like that. And you talk to any of those individuals, and they know from experience and from training that their ability to access multiple rule sets and options in the moments of extreme autonomic arousal is actually where their power lies, right? It's or a combat fighter, or let's just take, or in debate, right? Something that you're far more versed in than I am, right? Although I guess every academic has to deal with a bit of that coming up, thesis defense, et cetera. In a really good debate, you can't allow the autonomic response to overtake you, or you lose access to an enormous database that resides in one's hippocampus, and you essentially, one then defaults to the bodily state, right? And this is what we see when we see people become dysregulated in rage, et cetera. So if we were to zoom out and then ask, where is the line between exploration and anxiety? I think that we can check off a few boxes for sure. First of all, that autonomic arousal, this tendency to be more alert or more in action than in non-action, is a very healthy response. I mean, the moment adrenaline is released from the adrenals, and as you know, there's a parallel signal in the brain. You get adrenaline released from the adrenals if you get in a cold shower, or somebody says something triggering, or you are afraid of heights or something. But the brain has its own kind of adrenaline system, which is this structure in the back of the brain called locus ceruleus. It basically it essentially sprinklers the entire brain with noradrenaline and adrenaline. It's a very interesting system. It lacks specificity. It basically wakes up the whole brain. If I were to put a little, if I were to label the connections of the locus ceruleus, it's basically connected to everything. It just kind of sprinkles a caffeine-like substance on the entire brain, wakes you up. The adrenals in the body wake up the body. So two parallel systems wake us up.
Is that associated with the orienting reflex?
Yes.
If you orient, does the locus coeruleus wake up the brain?
Absolutely. Yeah. So it's a key component of the so-called reticular activating system.
Reticular activating system.
Yeah.
Yep.
And incidentally, I should mention this because I was going to come to this later, but I think it's relevant now. If somebody has a lesion in their dorsolateral prefrontal cortex, or if you transiently inactivate it with a technology, a non-invasive technology like transcranial magnetic stimulation, they can now just put a magnet on outside the skull and quiet that area of the brain transiently. In animals or humans, what you find is that person or human becomes incredibly accurate at any motor task. So for instance, if I were to give you a shooter game where you're supposed to shoot targets and you're shooting targets, you'll have some hits and some misses, like anybody. If I inactivate your dorsolateral prefrontal cortex, your accuracy goes through the roof. It's near 100%. But the one thing you can't do is decide whether or not you're shooting an enemy or a friend. So you can no longer establish rules. You just become very good at execution of the motor behavior. Similarly, in an animal or person without a dorsolateral prefrontal cortex,
you see a trade-off there, right, between specificity and flexibility.
That's right. And so we see this theme over and over again, where as a purely sensory motor response machine, the prefrontal cortex isn't even necessary. In fact, if you get rid of it entirely, people become like machines. If I click over here, somebody has no prefrontal cortex, basically everything becomes a stimulus. A puppy, everything's a stimulus. I used to have a bulldog. When he was a puppy, he had to worry about leaving cords out and everything went into his mouth. By the time he was, a year old, in part because he was a bulldog, he just kind of lay there. Like you could put a toy in front of him and he wasn't into playing and just leave it alone. A baby, everything's a stimulus. Many adults become infant-like in their responses, right? When anxiety is high. In fact, I have a friend who's a psychologist. Tell me if you agree with this statement or not, that anxiety makes children of us all. I don't know if that's true or not, but certainly has been my experience that when feeling anxious, I don't struggle with chronic anxiety, but I certainly have felt anxiety.
Well, it simplifies us. I mean, all these underlying emotions and motivational states, these primordial instincts, are simplification mechanisms. And so if we're unable to compute a complex and sophisticated pathway forward that takes multiple variables into account simultaneously, we can't just do nothing. We're going to default to a more primordial and direct state. And then you might say the whole panoply of emotions and motivations lies there at the weight for us to grip our behavior if we're paralyzed by inability to choose between multiple options. And so we do, to the degree that we're simplified by an emotion, then we're reduced to something more approximating an infantile state. If you watch 2-year-olds, and 2-year-olds are particularly interesting in this regard, they basically just cycle through innate motivational states. It makes them really interesting to be around because when they're interested in something, they're 100% interested in it. And then when they're angry, they're 100% angry. And if they're anxious, they're 100% anxious. And tired, they just instantly fall into a coma. And they just cycle through these with no overarching centralized integration. And it's partly because they likely don't really manifest any integrating prefrontal cortical capacity until they hit about 3, where they can start to engage in joint play states with other children, right? And then they can exercise, then they can modulate their underlying emotions in accordance with an abstract representation or goal, sometimes that's jointly shared. That's part of developing sophistication. It's also why the idea that identity is subjectively defined is absolutely preposterous. It's like, it's subjectively defined for 2-year-olds, but it's not subjectively defined for anyone who's sophisticated enough to negotiate with someone else. So tell me what you think about this. My understanding of the prefrontal cortex is that over the course of evolutionary time, it grew out of the cortex and that out of the motor cortex more specifically. And so the best way to think about what the prefrontal cortex does in some sense is that it generates potential abstract patterns of action. It generates them in abstraction so that they can be assessed before they're implemented. And so it's like it's generating potential future selves.
That's exactly right.
That's okay.
That's exactly right.
Okay,
and I'm glad you stated it, not I, because you stated it far more clearly and succinctly than I've heard it stated before. It's as if it's running plays. I'm using a sports analogy. It's running plays and thinking about potential outcomes. I'm not a chess player, although Lex Friedman's podcast and Lex Friedman are convincing me that perhaps I should learn, because there's a lot of discussion about chess nowadays, and there's a lot of thinking, as I understand, about potential outcomes. How many moves can you anticipate if this then that? It's sort of if this then that type of thinking. And if you think about its connectivity, it's in a beautiful position based on its access to priors through the hippocampus, so memory. It can take into account current state, bodily state. It can access information, for instance, about, do I have the energy? Do I have the resources to undergo a particular pattern of response? And that's through the insula and the ACC. And then the dorsolateral prefrontal cortex